We have here three exponential functions, and as we know, it is the base of the exponential function that allows us to predict whether or not we're dealing with a growth or a decay function. Now, if you take a look at these functions individually, at first glance, you would think this is a growth function because its base is greater than 1. You would think this is a decay function because its base is less than 1. And again, you would think that is a growth function because the base is greater than 2. In each of these scenarios, your intuition, your initial intuition, would be incorrect. And the reason is all three of these exponential functions have a negative sign in front of the x. So the focus of this video is to show that that negative in front of the x changes everything. And you cannot make an opinion as to the intuition of the graph unless there's a positive sign in front of the x within the exponent of the exponential function. First example, we are presented with this exponential function. And as mentioned a few moments ago, at first glance, this looks like a growth function because that base is greater than 1. However, we have to account for that negative in the exponent. So the first move here is to pull out the negative. And when we do that, we're going to get x plus 2 inside the parentheses. And whenever I pull out a negative, I always double check and redistribute. And if we do that, we'll see we'll have a negative x and a minus 2 matching the original exponent. Now, what we can do is take the reciprocal of the exponent and change, the reciprocal of the base and change the sign of the exponent. Now we see clearly that this is a decay function. Let's just go ahead and graph this. The way I graph these is to set the exponent complex to 0 and set the exponent complex to 1. I then solve for x. In this case, we're going to get x is negative 2, and here x is negative 1. Then I build a table, and I plug in the x values in to get the y. If we plug in x equals negative 2 here, we're going to get 1 over e to the 0 power, which is going to be 1. So our first point is going to be negative 2 comma 1. Next, we're going to plug in negative 1 into the original function. We're going to get 1 over e to the first power, which is going to be about 1/3 positive. So our second point is going to be negative 1 positive 1/3. Now that we have 2 points and we know the intuition, we could go ahead and sketch the graph. I should have mentioned that this graph has a horizontal asymptote at y equals 0. So we now have a decay function coming from above because this is a plus sign out front. So we expect this graph to come down and approach the horizontal asymptote. Here our first point is at negative 2 comma 1. And our second point is negative 1 comma 1/3. And we have a graph like so. Quickly looking at Desmos, if we were to plot that graph, you could see it's a decay function. Again, the point is, initially, that base looks like it's greater than 1, looks like a growth function, but in fact, it is the opposite. It is a decay function. Whenever you have a negative in front of the x, you're going to see opposite of what you initially note to be the base. Here, there's a negative in front of the x. Here, there's a negative in front of the x. Same here. So on this second function that we'll see in a minute, it looks like a growth function, but because of that negative, it's going to end up a decay. Here, looks like a decay function. Because of that negative x, it's going to be a growth function. And finally, looks like a growth function, it's going to be a decay. In fact, let's just go ahead and do each of those on Desmos now. You could see this one approaches the horizontal asymptote from below because of that negative out front. The horizontal asymptote is at +2. Here, the next one looks like a decay, but that negative, when you pull it out, it switches it to a growth function. It moves away from the horizontal asymptote from below. And finally, the third example looks like a growth function, but because of that negative in front of the x, when you pull it out, it's going to end up as a decay function.